So we're now ready to start talking about some of the operators in the observable class. And we're going to begin by talking about factory method operators. And if you recall, factory methods create stuff. It's the factory method pattern from the good old Gang of Four book. And these operators are used by programs to create observable streams in various ways. And we're going to talk about the just, from array, from iterable, and from callable factory methods in this particular discussion. There will be later discussions and later lessons about other factory methods. So let's start by talking about the just operator. This is very simple. It creates an observable that emits the given elements and then completes. You can see it has a very simple name, just. I'm not quite sure why it's called just, but it's called just. It probably should have been called emit or something, but it's called just. And it takes one or more parameters which are given as a variable argument list called a vararg. It returns an observable that's captured at assembly time. What the heck does that mean? It means that the thread where the call is made is the thread that emits the data. In other words, it's eager. So I put a picture of a dog that's looking expectantly, wants to go for a walk or wants a treat or whatever. And we're going to talk later about another operator called from callable that's lazy. So there's eager and lazy. Multiple elements can be emitted using just on an observable, unlike the just operator on the single class, which we'll talk about later. So single emits one element or fails. The just operator on observable can emit many elements. The typical use of the just operator is to adapt so-called non-reactive input sources into the reactive model. So here's a very simple example, which we'll look at more when we go through the code. This example is going to take a bunch of big fraction objects, and it's going to create an observable that will emit these four big fractions in that order in the thread that it was created in. And again, just is evaluated eagerly at assembly time. Therefore, it always runs in the context of the thread where the observable is instantiated. And we're going to take a look in a minute about a couple of other operators called from iterable and from array. These are factory methods that also are eager in their evaluation. The thread in which they are called is the thread in which they run. And that, by the way, can be a little confusing. So we'll look at some examples later. Project Reactor has a just operator in its Flux class that works exactly the same as the RxJava just operator on the observable class. And both of those factory methods are very similar to the stream of factory method. So here we can create a stream of four big fraction objects. Here we created a flux of four big fraction operators, big fractions. Here we made an observable of these big fraction values and so on. So the point I'm trying to make with these comparisons is this is all very much the same pattern. It's a factory pattern. It makes stuff, and all the different frameworks for streaming do things in much the same way. The from array operator is also eager, and it creates an observable that emits items from a built-in Java array. See here, just a good old Java array of type T. It's a static, it's a typed element, it's a generic method, and the parameter gives the array the data is read from, and it gives back an observable that emits the items in the array. Once again, we most commonly use the from array factory method operator to adapt non-reactive input into the reactive model. So here's an example. We have this array of integers, and we're going to create an observable stream of integer objects from this built-in array. Project Reactor has a from array method on the Flux class that works pretty much the same way. Make an array. You take an array and turn it into a flux. And also very similar to the of method in Java Streams, where you can give it an array. So interestingly enough, Java Streams uses an overloaded method to be able to convert either a varargs list, like we saw in the previous discussion of just, or an array. The same method is used for both. For some reason, RxJava and Project Reactor have different named methods, even though they could differentiate based on type. They could have had a just that would have been given an array. I don't know why they did that. There's also, just because there's many different ways to skin a cat in Java, you can also use the arrays stream factor method to turn an array into a stream. Works the same way as stream.of. I don't know why there's so many different ways to do the same thing, but that's the way it goes. The third type of operator is from iterable, and this is kind of interesting. This creates an observable that emits the items from the given iterable. And an iterable, as you may or may not remember, is an interface that's inherited by Java collection, and therefore all the collections, things like list and set and so on, that they all implement iterable. And that allows them to be able to be iterated on. And so we typically use from iterable to take something like a list or a set and turn it into an observable. Once again, it's adapting non-reactive input sources into the reactive model. Here we take, for example, a list of numbers, and then we turn it into an observable using from iterable. And gee, surprise, surprise, Project Reactor's Flux has an iterable that does exactly the same thing. And you can do something very similar with Java Streams, where you can use list of to make a list of something, and then you can say list.stream. So in streams, you say .stream to make a stream, or you could say .parallel stream to make a parallel stream. But once again, we're converting one thing to another. The final method here is a little different from the other ones. So at first, it looks the same, but it's actually slightly different. It's called the from callable operator. And it returns an observable that does certain things when an observer subscribes to it. In particular, what it does when the observer subscribes to it is it invokes a parameter of type callable. And the returned observable emits the value that was returned from the callable. Once again, this is most commonly used to adapt non-reactive input sources into the reactive model. So here's an interesting example to show this. So here's the use of from callable for observable. And what we're going to do is we're going to give it this callable that, when called, will make a big fraction randomly. So it'll emit one random big fraction. But what's interesting about this is every time someone subscribes to this observable, a potentially different big fraction will be created randomly. And that is because from callable is lazy. Remember before we talked about just and from array and from iterable, those were all eager. They ran in the thread where they were assembled. From callable runs in the thread when it's invoked. So it's lazy. It doesn't actually run until it's in the right context. And then at that point, the callable will be invoked, and in this case, it would make a big fraction, big random fraction. So it's lazy, unlike the eager stuff where the dog wanted to go for a walk and was pestering you incessantly till you took him for a walk or her for a walk. Here we have a cat, and the cat's lazy, and it doesn't really feel like doing anything. So compare and contrast lazy with eager. So from callable, lazy, from or just, from iterable, from array, eager. Important distinction. Project Reactor has a from callable method on the mono class that's very similar to the from callable method in the observer class. For some bizarre reason, Project Reactor has no lazy operator called from callable. If you want to do that, you have to stand on your head and do some extra stuff to get laziness from Project Reactor. But we're not doing Project Reactor, so it doesn't matter.